Hello.
Mr. Minsky? Mr. Minsky?
Yes, hey guys, how are you? Sorry for starting late.
Talking to it like that. The seniors
You guys have
an assembly at 3.
Gotcha. Okay, yes. Yeah, today we'll go until 3. If anyone has any questions, I'll stick around for a little bit, but yeah, I won't go over anything. Today I'm just going to go over some stuff about linear equations. So yeah, sorry I had to run the other day. I had a baby girl.
Yay!
Thank you. When Mama is feeling a little better, they're resting now. But I'll introduce you guys maybe next week. So it's been not much sleep the last few days. They're very fun. Thank you. So if I have to jump out during the lesson, you guys will know why. Okay, so yeah, today I'll just go until 3. I know some of you have an assembly, and those of you who are seniors, make sure to ask for details. I'm not sure exactly some sort of senior assembly. So let's continue. Just working through some examples of solving a system of equations. Oh, hang on. Let me share my screen. Okay. So today's lesson is solving 2 by 2 systems of equations. So there's two approaches. The first one is called substitution. First approach. First approach. Substitution. So here's a set of 2 equations, x plus y equals 7, and let's say 2x plus y equals 7, and y equals 3x. Let's see, 3x minus 8. Okay, so for many of you, this might be some review, so I'm not going to spend too long on it. But some of you might not have gone over this before, or might not have seen it in a little while. So this is just kind of, if you have seen it, I would be happy to hear your ideas. So this is something we call a pair of equations, a pair of simultaneous equations, and our goal is to find an x and y. So find a pair of points, or pair of numbers, x and y, that satisfy both equations simultaneously. Okay. So please hit yes if you see that for the first equation, there's a lot of different numbers. Like I can plug in x is equal to 2 and y is equal to 3. There's a lot of different solutions for the first equation, and there's a lot of different solutions for the second equation. The question is, how do we find a pair of solutions that would be that would work for everybody? So anyone want to volunteer kind of a nice idea here for solving this pair of two equations? This is why we call it a 2 by 2 system, because there's two equations and there's two unknowns. So I'll write in purple. This is two equations and two unknowns. And after we do this example, we'll finish up nice. Yeah. Awesome. Excellent. Getting a lot of good ideas. Does anyone want to speak up and share their idea? Anybody who wrote back to me? Go ahead, Kanjit.
Plug in the y equals 3x minus 8 into the y for the 2x plus y equals 7.
Exactly. If we want to find a solution that solves both of them at the same time, then we're allowed to replace one letter in one equation with another letter with the same corresponding letter in another equation. So we can just say that this red and purple, instead of using this y, which we don't know, we can replace it with the 3x minus 8. So we can just plug this expression into instead of y. And that would give us a new expression. We'd get 2x plus, and now I'll write it in purple. Just kind of underline it maybe. 3x minus 8 is equal to 7. Adding these together, doing a little bit of algebra, we get this is 5x equals 15. And then dividing both sides by 5, we get x is equal to 3. Okay, question, are we done here? What else remains to be solved? And how do we go about getting it? Anyone want to raise your hand? I can call on them.
Well, now we found x, so we have to find y, or?
Oh, perfect, exactly. Yeah, and Amy, how do we go about finding y?
You can plug in x into the equation. So 2 times 3 plus y equals 7.
Perfect. Can I use the other equation as well if I wanted?
Yes.
Excellent. So you could use either equation. Now that you know one of the numbers, as soon as you know one number, the other number is automatically determined. So we can plug in, like Amy suggested, let's just plug in 2, I'm going to write here, I'll just write it on the side, 2 times 3 plus y is equal to 7. And then that gets us to the answer, y, or the other variable that we didn't know. Now we know that y is equal to 1. Okay, very good. And this is called just plug in one solution into either equation. All right. And now we have we figured out our pair of x, y values. The answer here is, the final solution is, we write it as a point where we give the first number 3, and then we give the second number 1. This is the convention. Maybe we can just write it to make it more clear. Whoops, like this. This is x, y is equal to. All right. Very good. Are there any questions about substitution? Okay, so now let's try another example. And we'll see the kind of both. You can use both examples as you like, but we'll most of the time be using the next strategy. So let's do view, single page. Let's do the second solution, or second approach. So let's try to solve this one. 3x plus 4y equals 18, and let's see. 19, 17, and okay. So the second approach is called elimination. So now we have two equations. Sometimes they'll be you can kind of give them as like equation 1 and equation 2. In the next chapter, we're going to do 3 equations and 3 unknowns. So you'll need to be really organized when you do those, and I'll show you kind of how to work through those steps. But for 2 by 2, you can just kind of do line by line. You don't really need to label the equations. So anyone have any ideas? Well, first, let me ask, and speak up or just hit the yes button. Do you guys know what are these equations of? And yeah, well, like what picture? If you were to graph each equation, what would you get? Excellent. So this is kind of a point that I didn't emphasize. When we're talking about these two equations and two unknowns, the equations that we'll generally be talking about are equations of lines. So these are both equations of lines, and maybe I'll just mention over here. I'm going to put in here, just to make a little asterisk, something called a linear equation. And in general, anytime somebody talks about a system of equation, they usually refer to a system of linear equations, where each equation has variables that are only showing up once. There's no like exponents or weird like square roots or anything like that. Excellent. And in this case, these lines aren't written in y equals mx plus b form. Does anyone know what the name of the format for each line is? Like how it's written? There's kind of like it's the way that it's written is called something. Mx plus b would be kind of like the last one that we saw for y equals 3x minus 8. And it's not slope intercept. Really nice. Yeah, it's ax plus by equals c. There's a name for that form. Anyone want to take a guess? Nice. Really excellent. This is called standard form. So whenever you have two equations in standard form, and you can always go from mx plus b form to standard form. Standard form is equations that are, so let me just kind of put it here. So reminder, standard form is ax plus by equal to c, where a, b, and c are thought of as like constant numbers. Uh-oh, yeah, let me actually, I'll be right back. So I'm going to give you guys a few minutes to solve this one out, and then when I'm back, I'll plug in my iPad. Thanks, Kanjit. Yeah, hopefully somebody can walk us through how to do it. I'll be right back. So, any volunteers to share their idea?
Don't you have to make one of the variables cancel each other out? Like, can't you multiply the second equation by 4, like all parts of it, in order to make the y terms cancel out?
Awesome, Jay. Yeah, exactly. Yeah, so the elimination technique is you want to somehow line up the equations so that, exactly like you said, the coefficients of either the x variable or the y variable will cancel out. that's a really good observation, that this has a 4 in front, and this is just the, there's not just a minus sign here. So if we can multiply everything through by 4, the second equation, we'll get another equivalent equation, because you're always allowed to multiply, like if you know like the number of apples you have equals the number of bananas, for example, then definitely, you know, you can multiply both sides by 4 and still that the information from that equation is still exactly the same. So let me just kind of erase that. So Shay, that's a really good idea. We multiply everything here, we get 8x minus 4y equals 16. Okay, and what can we do next? How does the elimination step work here?
Wouldn't you add all the terms together? So like you'd add the 3x and the 8x together, and then you'd combine the y so they cancel out. Or wait,
Yeah, that's perfect.
yeah, and then you'd add the 17 and 16 together.
Awesome. And it looks like when I was trying to come up with this problem, did I make a mistake here? 11x. Oh no, that's good. Yeah. So this is going to be equation 1. This is equation 2 times let me call this times 2. Equation 2. And then after that, this will be equation 3. And now you can combine equation 1 plus equation 3. And as you do that, you get 11x is equal to 33. Okay. And now you can solve, and you get x is equal to 3. And now that we have x equals to 3, what can we do with that information? Yeah, Archer, nice. We can just plug it back in. So just like in substitution, once you find one of the variables, you can plug in and find the other. So now we can plug back in for x in either equation. So then we can do x equals 3. We plug it into the first equation. Let's say let's plug into the first equation. Equation 1, we get 3. I'll do this here. So x equals 3. 3 times 3, that's x, plus 4y is equal to 17. This is 9. This is 9 plus 4y equal to 17. Subtract 9 from both sides. We get 4y is equal to 8. Or in other words, dividing both sides by 4, we got that y is equal to 2. Okay. And now putting those two variables together, those two solutions, we have our solution is xy is equal to 3, 2. Okay.
Where you put the 2 times equation 2 part, wouldn't it be 4?
2 times equation 2. Oh, hang on. Did I make a mistake here? That's where did I? Oh, yes, I see. I got worried there that I multiplied by the wrong thing. Thank you. Thank you for catching that. Okay, so please hit yes if you're comfortable with this approach, and hit no. Also, let me know or message me if you haven't seen it before or you're a little bit shaky on it, and I'll assign some problems where you can review this. If you have done this before, you don't have to do all of the actual practice on the algebra. I'll care more about the setup of the word problems and kind of following through from there. But this is kind of definitely a really good foundation to have. Okay, so let's do one more approach. And they talk about this. This is actually probably the most important conceptual approach to have, because I would say approach 1 and approach 2, their substitution is very formulaic, and so is elimination. Oh, the beginning part? The beginning part is, I didn't really explain that very clearly. That is to say, pick a variable, first pick a variable to eliminate. So pick a variable to eliminate, and multiply by something. So both equations, maybe I can kind of copy, move this all down. So the approach is pick a variable to eliminate, and multiply both equations by the appropriate constant so it is easy to cancel that variable. And in this case, we saw plus 4y and minus y. And so Shay mentioned that, oh, we should just multiply everything in the second equation by 4, and that will give us a plus 4y and a minus 4y, and those, when you add them together, will cancel. Sometimes you get equations, and different teachers teach it different ways, and I'm okay with any way that you like. Some teachers will say, okay, set it up so that the coefficient in the variable that you want to eliminate is the same, for like exactly the same, and then subtract both equations, like subtract one equation from the other. And this way, that will eliminate the other variable. I just personally don't like subtracting equations. I like to make one of the variables be the negative sign of the other, so that this way I can just add equations. It always makes me nervous to subtract equations because I'm worried I'm going to kind of forget a double negative somewhere. So it's totally up to you how you like to do that. Let's try you guys do one example of elimination, and this one will be from the book. Actually, let's try the one that we had. Do I still have it here? Ah, yes. Let's finish the one that I had to go last time. Where was it? We did that. Ah, so this is the word problem. And this time the equation isn't for X and Y, it's for P and S, but we can do the same approach. So I'll give you guys a few minutes here. Try to solve this using either method of your choice. If you are not super comfortable with elimination, use elimination. But if you're comfortable with both of them, solve it with either one, and then send me the ordered pair P comma S when you're done. Or if you need some help, just shoot me a message. I just got one answer so far. Message me if you're stuck and not sure how to approach it either. All right, a bunch of students messaged me that they're a little bit stuck, and I'm actually really happy to hear that. Would any of you be willing to kind of walk me through what your ideas are so far, and where you're stuck? Because it's also helpful for a lot of other students who see that, who are also stuck, to kind of see that other students are having a little difficulty as well. So where are you stuck? And you can also message me privately as well. Yeah, Amy, go ahead. Walk us through.
Okay, so what I did was set up the equation so it would equal one of the letters. So 5
Nice.
equals P plus S looked like simpler to do. So what I did is I subtracted P from 5. So 5 minus P equals S.
Hang on, Amy. I'm just going to write. So which approach are you using here?
I think a substitution.
You're right. Nice. Perfect. So let's do this as a substitution approach. And so you did subtracted P from both sides, and you got, was that you said subtracted P? 5
Yeah.
minus P equals to S?
Yes.
Excellent.
So then I plugged that in, 5 minus P into the first one. So 19 equals 5P plus 3, and then parentheses 5 minus P.
You got it. Nice. And whenever you do substitution, parentheses are really important because you got to be careful with distributing. Great job. So you get 19. And if I write something wrong, please stop me. 5P plus 3 times 5 minus P. Looks good?
And then I just multiplied the 3 to 5 and negative P.
Mm-hmm.
And I rewrote the whole thing again. So 19 equals 5P plus 15 minus 3P.
Awesome. And it's okay, by the way, just make a comment. It's okay to, when you're doing these, to just rewrite, like if you do a step of algebra, feel free to just go down and make a new line. You don't need to write everything in one long equation. And that's a really dangerous kind of habit to get into. it's good to, if you're doing something to both sides, just make a new line. Or even if you just want to simplify stuff. Sorry, Amy, go ahead.
Sorry, there's a lot of noise in the background.
Oh, no worries.
So from there, I just combined 5p negative 3p, so 2p, and then 19 minus 15.
Perfect. So 19 equals 2p plus 15. Then we
Yes.
subtract 15, we get
4 equals 2p.
4 equals 2p. And therefore,
P equals 2.
p equals 2. And which one did you like to plug into?
I plugged it into 5 equals p plus 5. S, sorry.
Excellent. Yeah, my S looks like, definitely looks like a 5. Excellent. So you can plug back in, and you get S is equal to 5 minus 2, which is equal to 3. Excellent. Well done. Okay. Amy, that was really good. Are there any questions on substitution, the substitution approach here? And I will never ask you to like do one over the other, but elimination, the general idea of elimination will be, I think you guys will find that one a little bit easier to do in the future. And it's also easier to apply to 3x3 systems. So it will be important to know how to do that. So anyone want to volunteer how they set it up with elimination? I saw a few of you did it with elimination as well.
I did elimination.
Yeah, go for it, Lily.
So I multiplied the second equation by -5 so I can eliminate the 5p from the first equation.
You just paste it. Nice, really excellent. So you multiplied you said the second one by -5?
Mm-hmm.
Okay, so I'm going to write it here. And one thing that I like to do, which is, it's a little bit repetitive, but I always like, if I'm planning to use the second one to eliminate something from the first one, I like to just write them like right on top of each other, the ones that I'm going to eliminate. I don't like to, in the actual example that I didn't rewrite that equation when I was going to do the cancellation. So this would be negative, this is negative 25. This is going to be -5 times equation 2. Just kind of put a little note on the side. So this would be -5 minus 5p minus 5s. I'll cut this over here, put it over here. Okay, and then from here, what would you do?
I just canceled out the 5p on both of the equations and then added the other terms.
Exactly, and this is something that if you haven't seen it before, it's a little bit weird to like add the left sides of two equations and the right side of two equations. But if you think about it, it's definitely a valid thing to do, because you can always think of equations as like scales. So if you have two different scales that are both equal, then if you add the left sides and combine them into one scale and the right sides and combine them into another scale, then those should also still be equal. So that's what allows us to kind of combine equations like that. So this will be -6 equals -2s. And now we get s dividing both sides by -2. Just kind of always be careful with the negative. This is gone. So this is going to be 3 is equal to s. And Lily, what did you go from here? Which one did you plug back into?
The second one.
Awesome. Okay. Oh yeah, the overall second equation. Yeah, I like that one too. And so then you get plugging back in, you get 5 equals p plus 3. This tells us that 2 is equal to p. So our point P comma S is equal to 2 comma 3. Okay. Those of you who were a little bit unsure and a little bit stuck, message me if you feel a little bit better after seeing kind of these explanations, or if there's still some spot where you're a little bit unsure why we did something. Awesome. Okay, so one student asked, why do we multiply by -5? That's a good question. So that's the heart of elimination. That's why we're that's what kind of makes everything work out. So the observation is that both of these equations, total revenue and total items, are both written in standard form in terms of the variables P and S. But if you notice, the first equation has a 5P, and if you want to try to eliminate P, it would be awesome if the second equation, instead of a regular just 1P, it had a negative 5P. But we can create that. We can create that sort of situation just by multiplying the entire second equation by -5. That allows the 5P and the negative 5P to cancel. What's another thing we could have multiplied by to make the equations cancel, or make a variable cancel? And the cool thing about both of these solutions is that there's not just one unique way to do it. Nice, Ariana, very good. So Ariana suggested multiplying everything in the second equation by -3, and that would just get you to solve for P first, and then plug in to solve S. So it's a perfectly good approach as well. Did that explain kind of why the -5 showed up? We kind of picked that number on purpose to cancel the 5P. Okay, last few minutes, I want to just talk about the general idea for what's happening kind of behind the scenes here. So let's look at this. Let's look at this pair of equations that we had before. I'm going to go back to this one. Oh, it's October 1st. Nice. Okay. So yeah, let's go to this equation. So the question is, what is the picture or geometry behind the algebra? And we'll just talk about this example, and then next time we'll kind of delve into it a little bit more. So, oh, wait. How do I undo that? Okay, what was it? 2x plus y equals 7, y equals 3x minus y, 8. So 2x plus y equals 7, and then y is equal to 3x minus 8. So we talked about in the beginning of class how these are both equations of lines. And the second equation is written in mx plus b form. the first equation is written in standard form, but for this idea to understand what it looks like, let's rewrite it as mx plus b form. So remember, y equals ms plus b form. You just isolate for y. You write y equals, in this case, it would be negative 2x plus 7. In the examples where it's standard form, but there's also a number in front of the y, you not only have to move over the x term, but you also want to divide by whatever's in front of the y. So that would be a case where you sometimes get a weird slope that's a fraction. But now what are we looking for? These are both equations of lines. Let's just quickly, oh, you know what? Let's see if I can do this here. Paper, let's do a little graph paper. Cool. Let's plot these two lines and just kind of sketch where they go through. Let me kind of see if I can do that. Oh, it doesn't do that feature. Okay, so this is our axis. It's a little bit intense. Let's go back to this one. And if we know that the first equation is negative 2x plus 7, well, we know that the first line will have an intercept of positive 7. So 1, 2, 3, 4, 5, 6, 7. And it will have a slope of negative 2. So every time you go 1 to the right, you got to go 2 down. Sorry. And so this is the first equation. And I'm going to try my best to draw it here. Okay. The second equation is y equals 3x minus 8. So let's see here. I'm going to continue, we'll make it green. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that's the y-intercept where it starts at. But now it goes up by 3 every, uh-oh. I might have not counted correctly. 1, 2, 3, 4, 5, 6. Oh no. Let me see if I can do this. Yeah, I just miscounted, I think. Then count all the way to. So let this go through here. And so what you find here is, in order to find a point, okay, I'll let you guys go. If you have to run to the assembly, the only point of this was to show that there's a graphical solution which represents the intersection point of two lines. That's what's really happening here. All right, guys, I will see you on Tuesday. I will post some homework so you guys can review this and maybe do a little bit of reading to get ahead. But mostly just practice getting comfortable with elimination and substitution. All right, I'll just kind of finish through talking about this example, and I'll continue talking about it on Tuesday. So if you have, go for the assembly if you have to run. There's nothing that won't be covered next time. Thank you, Archer. Okay, so so just the comment here. So if you observe here, oh, the crossing point, this is one point that exists on both equations at the same time. And this is the point x equals 3 and y equals 1. And if you recall, that was the solution that we got last time. So this brings up an interesting sort of question, is what are the possibilities? Like if anytime I write two equations and two unknowns, can I always get an answer? And we'll talk a lot about this next time. But what do you guys think? If I write any two random equations, am I guaranteed to get an answer, or exactly one answer, or what's something funny that can happen? Anyone have any ideas? You might get a fraction. Ah, Hannah, you want to share your idea? Very good.
I thought that they could be parallel, so they wouldn't have a point of intersection.
Exactly. So just check out this example. We'll see this kind of show up in more, not as obvious examples. But what do you guys think about this? So now that we know that what's happening when we really search for x and y is we're just looking for a point of intersection of two lines. And Hannah suggested a way that, hey, if we think about two lines that are parallel, now let me go back to normal size. If you have two lines that are parallel, let's say something like this, then by definition, they never cross. So one example of a system of equations that would give you some trouble would be the following. What if you wrote y equals x plus 2, or 2x plus 2, let's say, and y equals 2x plus 5? What would happen here if you tried to do substitution? Let's plug in. First, before I say that, does everyone see that these two equations are parallel? Can anyone tell me why these two equations are parallel?
They have the same slope.
Excellent, yeah, they have both slope too. And remember, slope is kind of like the direction in which the line is going, and the intercept tells you how high it starts. So they both have the same kind of slope, they're both going to be parallel. And that's going to be a key fact that we use. So being aware of parallel equations or looking for that is really, really important when you're trying to solve a system. Okay, so what happens that's kind of weird if you try to do substitution? Like let's say plug in the second y, like the 2x plus 5, instead of the first y. What would be something iffy that happens?
Wouldn't like the two x's like cancel out,
Yeah, exactly.
giving a new slope?
The two x's cancel, so I'm going to plug in this expression for this y. And then I would get a new equation, 2x plus 5 equals 2x plus 2. Subtract 2x from both sides, and then, whoa, we have 5 equals 2, which is false. This doesn't make sense. So that tells us that, hey, no matter how you try to solve it, it's not going to work out. There's not going to be any answer, because if there was an answer, then 5 would equal to 2, and that doesn't make any sense. So it's a bit of a weird way to think about it, but I find it just easier to think about, well, the slopes are the same, the intercepts are different, therefore there's no solution. So we call this inconsistent. It's just a fancy way of saying no solution. Okay, and then the last kind of idea here. Are there any ways for there to be more than one solution? And it's kind of a tricky answer. It's not super interesting, but can anyone think of a way for there to be more than, for two lines to intersect in more than one point. Oh, two linear. So Hannah made a good point. You could, yes, there will be times, not in our course, but there are situations where you have like curvy lines, and curvy lines can definitely intersect each other more than once. But can two straight lines ever intersect each other more than once? So it's kind of like a cheap answer. So what's it called? It's like not like a riddle, but so how could two lines ever intersect each other more than once? What do you guys think? There is a way. So a few of you are saying that they can't, and I agree with you. It's that you guys won't like the answer when you hear it. Well, let's just do an example first. So Kanji has a good idea. If one of them had a negative slope and the other one had a positive slope, then they would cross somewhere, right? So as long as the slopes are different, they're definitely going to cross. It's when the slopes are the same that when you get some weird situations happening. So just take a look at about this example. And tell me what you guys think about this. Y is equal to, or let's do it like this. X plus y is equal to 5, and 2x plus 2y is equal to 10. So let's just try elimination on this. Anyone want to volunteer elimination? We can just walk, even if you haven't done it, we can just walk through the example.
To the first equation, multiply by 2, -2.
Excellent. You could, if you want to do subtraction, if you don't like to multiply by negative, whatever you like to do, yeah, I like that. So multiply by -2 to cancel the x, so that'd be -2 minus, oh, my bad, that's minus 2x. Minus 2x minus 2y equals minus 10. I like to put a bar, like kind of remind myself that I'm combining them. And then what do you get on both sides?
0.
0.
Yeah, you get 0 equals 0. So what happened here? What's going on? Any thoughts? Any observations? There's something funny that happened here. How about we write both equations in standard, in mx plus b form? And then you'll see something not super surprising. Nice, Savannah, excellent. So if we write the first equation in mx plus b form, we get y equals -x plus 5. And the second equation we have to do, let me just kind of move it over here. This will be right here. The second equation would be, I'm going to move over the -2x. We get 2x equals 10 minus 2x, dividing everything by 2 to get y by itself, and rearranging it, I get y equals -x plus 5. So what's going on here?
Same line.
It's the same line. Even though equations look different, do you guys agree that if equations look different, they might still actually be the same set of, they might still represent the exact same set of points? It's not immediately obvious, but once you see it, it's like, oh yeah, that makes sense. If I have an equation of a line, I could multiply it by anything I want except 0 and get a new equation, but it's kind of like, it's a lot like fractions, right? there's many ways to write the same fraction. Like 3/6 is the same as 1/2, which is the same as -2 over -4. So in math, it's very valuable to think about things that look different but are actually the same. All right, now what do we know about two equations? How many points do they intersect in? Sorry, two lines that are the same.
All of them.
All of them. They always overlap, so there's an infinite number of solutions. So this is two lines have an infinite overlap. And so that's basically like saying, oh, what are the solutions to y equals -x plus 5? Well, there's an infinite number of solutions. I just don't have enough information to tell you what is the x and what is the specific y. I can tell you that how they're related, but I can't tell you a specific point. And so this is called, whenever you get a system and it simplifies to 0 equals 0, and you didn't get any answer to any actual variables, this is called the indeterminate. Indeterminate. So indeterminate means you can't determine the answer. Answer the infinite solution. Infinite solutions. Okay. So in the homework, you'll encounter these and see this idea. And then there'll be types of questions which will be like, oh, what possible coefficient would make this have one solution, 0 solutions, infinite solutions? So you'll be asked deeper questions that test your understanding of not just finding how many solutions there are or what are the solutions, but kind of how to set it up so that you get a specific number of solutions. And all it boils down to is, are you setting it up so that the lines are the same or cross somewhere? All right, guys, are there any questions on what we learned today? Kind of the idea of elimination, substitution, or visualizing the geometry or the picture, the graphs behind all of the algebra and these interesting cases. All right. Well, thank you guys for participating. I'll stick around if anyone has any questions in general about either like midterm or homework so far. But otherwise, I will see you guys on Tuesday. And please be on the lookout for a homework assignment that I'll post later today.
Have a good
Oh yeah, I'm sorry. I'll see you guys on Monday. Yes, my bad. My other class on Monday. My other class on Tuesday. Sorry. I will see you guys on Monday.
Do we have a test coming anytime soon?
No, not for about 3 weeks or so.
Okay, thank you.
Mm-hmm.
Congratulations.
Thank you. Thanks, Sanjeev.